All right, let's see how far we can get with this. Again, I doubt, when did I say this was over? I forget. 10, 50? Okay. All right. All right, so let's do this. I got some it says right here, properties of real numbers. I'm going to list 4 of them, and we're going to talk about them just briefly. I'm not going to dwell on this, but I do think it's important to know. I could put property after every one of these. I'm not going to. I'm just going to put the word. So this is a reflexive property, symmetric property, transitive. Do you remember these words at all? Transitive property and substitution property. And there's another one. Transitive. Trans, T-R-A-N-S-I-T-I-V-E, transitive, and then substitution. Substitution. Okay? So I'll just give you a quick little synopsis of what each of these things mean. I mean, this one, it seems like why would you even have to say this? This is crazy. But A equals A, all right? Or if you put a number in there, you can say 3. What does 3 equal? It equals 3, all right? Well, of course it does. Something equals itself. You actually use that a lot in geometry. You had me for geometry, but I'm not going to take you back there. We use this thing called the reflexive property a lot, or a little bit, in geometry, and that's really where you use it more than in algebra. Symmetric property says this. It says if A equals B, then B equals A. All right? So if something is symmetric, like if you look at a picture, if it was symmetric, like if you put a line right down the middle, all the stuff on the left looks just like the stuff on the right. Okay, that's kind of what that is. So that's what the symmetric property is. So for instance, if 3 equals 5, then by the symmetric property, 5 must equal what? I'm sorry, 3 equals 5. That's dumb. I meant to put an X here, not a number. If, let's say, X equals 5, then what? 5 equals X. Or you could say this. If, let's go super easy. If 1 plus 2 is 3, then 3 must equal what? 1 plus, 2. You get it? All right. Again, it's kind of self-explanatory. And you look at it, you're like, why do people even have to come up with a name for this? It's kind of silly. But again, we use this a lot in geometry. But this is what this says. Now, transitive is kind of interesting. It's this. If A equals B and B equals C, then, take a look. If A equals B, right? So A and B are the same. And if B, the same thing as A, is equal to C, then tell me something about A and C. Well, A equals C, doesn't it? Okay? So that's the transitive property. So that's getting a little bit heavier than this other stuff. So if A equals B and B equals C, then A and C are exactly the same. I'm not going to do a little example because I'm just running out of time. I want to keep going. Substitution. Basically, it says if A equals B, then I hate the word that they use the word substitute in a definition for substitution, but, or let's say this, we can replace. How about that? They actually say we can substitute, but I don't like using the same word when you're trying to define it. So if A equals B, then when we can replace B in for A. All right? So if A and B are exactly the same, and I had like, what is 3 plus B, and I knew that A was equal to 5, this is basically what it's saying. If A equals 5, and this is 3 plus B, and if I know that A and B are equal to each other, what could I write? I could write 3 plus what? 5, because A is 5 and B is 5, then you go 3 plus 5. All right, that's substitution. We've done a lot of that. Okay, here's one that we use a lot. I don't know why it's not in the first four. They kind of put it by itself, but it's called the commutative. Usually I would probably list this with the other four, but they don't. It doesn't seem like they do on here. This is called the commutative property. This is one we talk about a lot. And you have a commutative property for, you have two of them. You got one for addition, and you got one for multiplication. All right, let me show you what that is. Here's what the commutative property says. So it says if you have a plus b, that's going to be the same thing as b plus a. So if I have 2 plus 3, it's going to be the same exact thing as 3 plus 2. We're going to talk about subtraction and division here in a second. What about multiplication? Is there a commutative property for multiplication? Yeah. What if I have a times b? What do you think the commutative property says about it? If I have a times b, that's the same thing as what? B times a. Very good. See, all we did was just switch the order, right? We just switch the order. A plus b is the same as b plus a. So that works for addition. I mean, think of any number at all. Think of, I don't know, 3 plus 5. Is that the same as 5 plus 3? Sure it is. Let's put a negative in there. Let's say negative 2 plus 7. All right? Is that the same as 7 plus negative 2? Yeah. That's 5. That's 5. Yeah, it works. Is there a commutative property for subtraction? Let's think about it. Is 3 minus 2 the same thing? I'll put a question mark over it. Is 3 minus 2 the same thing as 2 minus 3? That would be the commutative property of subtraction. But is it true? Does it work? Is 3 minus 2 the same thing as 2 minus 3? No, it's not. What's 3 minus 2? It's 1. What's 2 minus 3? It's negative 1. Are they equal to each other? No, they're not. So is there a commutative property of subtraction? No. What about division? What's 12 divided by 3? What if there was a commutative property of division? That must mean that what? 3 divided by 12 must be the same thing. Is 12 divided by 3 the same thing as 3 divided by 12? No, it's not. Okay, so they are not equal to each other, so there's no commutative property of multiplication. Make sense? Addition and multiplication, perfectly fine. Here's another property that we're going to do. This is called the associative. Easy for me to say, right? Associative property. All right, here's what this says. It says that if you have this, now I'm going to write a little bit more in a second to this, okay? But I'm just going to write a plus b plus c equals a plus b plus c. Now, if I asked you to add 3 numbers together, in your head, you're not really adding all 3 together at the exact same time. What are you really doing if I told you to add 3 numbers together? Aren't you adding like the first 2? You get an answer, then you add the third one to it. In your head, that's what you're probably doing. Okay, that's what I'm doing anyway. Even on very simple numbers, 1 plus 2 plus 3. I'm not doing that all in my head at the same exact time. I'm thinking, oh, 1 plus 2 is what? 3, and then 3 plus 3 is 6. That's how I add. Is that how you add? Unless you're some genius person and you can just do it like that. I'm definitely not that. So the associative property says if I add the first 2 together and then add the third one to it, it's the same exact thing as if I added the second 2 together, all right, and then added it to the first one, like 1 plus 2 plus 3. I could have gone 2 plus 3 first, couldn't I? All right, that's what? 5. Then add it to the 1, it's still 6. You still get the same exact answer. What allows you to get the same exact answer? The associative property tells you you're going to get the same exact answer. So look, the A, B, and the C are in the same order. It's just how we group them, how we associate, right? You've heard that. Don't associate with those people over there. What does that mean? Don't be in their group. You follow me? So you're grouping them together. So you group these 2 together, then you add this one. and it doesn't matter how you group them. This one we grouped these two together. Or if you wanted, you could group the A and the C together, couldn't you? And then add the B. So that's the associative property. Let's do multiplication property. I'll just put MULT just because of time. It's kind of the same, well, I'm sorry, it's not the multiplication property. We have the associative property, we have two of them. We got one for addition, and we have a second one for, what do you think? Multiplication, all right, that's what that is. So I'm going to put A, B, and C. There's no pluses in between. And then I'm going to put A, B, and C for here. Again, it's the same exact thing, except instead of adding them together, we are going to multiply them. So you could take the first two, multiply them together, then multiply by the third number. Or you could take the second and the third number, multiply them together, then multiply by the first. You'll get the same exact thing. So you got the associative property for addition and the associative property for multiplication. We got one more, then we'll leave the rest for tomorrow. And we kind of know this probably already, but we're going to do it again. Most of this should be review. The distributive property. So the distributive property says if you have a number that's being multiplied by two things that are being added together, do you see that? These are being added together and this is being multiplied. We did this earlier today, didn't we? So what's the distributive property tell you? It says that I can take that A, multiply it by the B, then take the A and multiply it by what? The C. You guys see that? You know that, right? You've known that for a long time. So what would this equal then? It'd be AB plus what? AC. And that's what the distributive property tells you. That's good enough. All right. So we can finish this up tomorrow. I'm not going to give you any homework on this tonight. And I think that's good. Let me just check the lesson plans. Yep. So hopefully, I don't know, it might take another 2 days to finish this R-1. Okay. All right, so it'll probably take another couple days. So probably early next week we'll take a quiz on this stuff, all right, on all of section R1. Is that all right? Yeah. I know it's real basic right now. Some of you guys are probably loving that it's really basic. It's not getting so hard. It's going to get harder, all right? When we'll start doing stuff that you haven't seen before, all right, or you have seen before but you didn't know how to do it, all right? So we'll see how it goes.